Welcome, Focus Learners. Today, we're taking a pretty fascinating journey. We are going to take the standard Class 7 math syllabus and turn it into a total real-world adventure. Seriously, if you've ever felt like math is just a bunch of abstract numbers floating around on a whiteboard somewhere, this explainer is going to completely change your perspective. We're going to see how these foundational concepts literally govern the entire world around us. Right off the bat, let's dive into a massive question. Have you ever wondered why we even need negative numbers in the first place? Or, say, how fractions dictate the way you share your snacks? We kind of get stuck thinking of math as just a school subject, but it's really a language. It's a language used to describe our reality, from the games you're playing to the chocolate you're splitting with your friends, all the way to how giant businesses track their success.
We've got a super clear roadmap for this explainer today. We'll be hitting 5 key areas: counting and number lines, demystifying integers, integer rules in action, fractions and decimals, and finally, data handling essentials.
All right, let's kick things off right at the foundation with Section 1, Counting and Number Lines.
You know, before we jump into any crazy complex equations, we actually have to start with the physical world. To make learning tactile, especially when you're first trying to grasp how numbers relate to one another in space, it really helps to start counting using physical objects. Think about using monster toys or maybe toy cars. Once you can visualize, say, 3 toy cars sitting right next to each other, then you can move to drawing a DIY physical number line on paper. Getting that physical representation down really cements the idea that numbers follow a specific, unchangeable order.
Moving right along, let's jump into Section 2, Demystifying Integers.
So what is an integer? Simply put, integers give us the vocabulary to talk about having absolutely nothing, which is our 0, or even having less than nothing, which gives us our negative numbers. But notice what is not included here. You won't find any fractions or decimal points. An integer is always a perfectly whole number, whether that's a positive 10, a 0, or a negative 5.
Let's put this into the real world. Say you've got 5 apples, and your very demanding friend Jerami snatches 3 of them away. We easily use basic subtraction to see you've got 2 left. Easy, right? But what happens out there in the real world when a business starts with exactly 0 money and then still incurs a loss? The business doesn't have any physical apples to give away, but the financial loss is incredibly real. Suddenly, to track that abstract loss, we absolutely 100% need negative integers.
Now for the really fun part. Section 3, Integer Rules in Action. Okay, so now that we've got these negative numbers floating around, we definitely need some rules to play fair. Let's look at the commutative property. Imagine Rami and I get into this huge argument about how to add numbers. I say 2 plus 3 equals 5. She insists, no way, 3 plus 2 equals 5. So who's right? Well, we both win. The commutative property tells us that for addition, order just doesn't matter. Adding A plus B is the exact same thing as adding B plus A. And then we have the sign rules for multiplication. There's this really fascinating quirk here. Multiplying 2 negative numbers magically creates a positive result. A plus and a minus make a minus, but 2 minuses totally cancel each other out to make a positive. It's honestly just like using a double negative in English grammar. Next up is an absolute lifesaver, the distributive property. It's a fantastic shortcut. When you use this property, you've got a number sitting outside a pair of parentheses and numbers being added or subtracted on the inside. Just think of it as handing out a little piece of that outside number to everyone waiting patiently inside the parentheses. You multiply the outside number by the first inside number, then by the second, and combine them. It keeps the whole shebang perfectly fair and balanced.
And hey, never, ever forget the multiplicative property of 0. You can have the most massive, complex number in the universe, but if you multiply it by 0, it all vanishes. It's exactly like putting 100% effort into a relationship where the other person gives absolute 0 back. No matter how hard you try, the mathematical result is always, inevitably, 0.
Let's pivot a bit and check out Section 4, Fractions and Decimals.
Integers are great and all, but let's be real, the world rarely deals in perfect wholes. Just think about this incredibly relatable tragedy. You go out and buy a 5-rupee Dairy Milk chocolate bar, and it comes with exactly 3 pieces. But before you can even take a bite, your friend claims 2 pieces for themselves, leaving you with only 1 single piece.
So how do we represent your sad, tragic share of the chocolate? You're left with exactly 1/3 of the bar. It's written as the number 1 over the number 3. This represents your specific part out of the entire whole. And that brings us to the formal definition of a fraction. It's simply a way to show a part of a whole. The top number, which is called the numerator, is the slice you actually get to eat. The bottom number, the denominator, is the total number of slices that existed in the first place.
But wait, what happens when you actually need to divide by a fraction? I know it sounds like a nightmare, but there's actually a brilliantly simple rule. First, keep your first number exactly as it is. Second, change that division sign right into a multiplication sign. And finally, take the second fraction and flip it completely upside down. In math, this is called finding its reciprocal. Then, you just multiply straight across. Keep, change, flip. It works every single time, I promise.
All right, final stretch, Section 5, Data Handling Essentials. Let's figure out how to make sense of huge, messy piles of numbers. Because having data is one thing, but actually understanding what it's telling you, that's the real superpower. Imagine your friend Ashish studies different amounts each day. On day 1, he studies for 4 hours. Day 2, he's feeling super motivated and hits 5 hours. Day 3, he's exhausted and drops to 3 hours. If someone asks Ashish how much he studies, it's pretty hard to quickly explain his fluctuating habits day by day, right? This is exactly where the mean or the average completely saves the day. Instead of listing out every single individual day, Ashish can just calculate the mean. He adds up his hours, 4 plus 5 plus 3, which equals 12, and then divides by the 3 days. Now he can proudly and completely accurately say he studies an average of 4 hours daily. It just simplifies the whole story. But what if we're looking at a much larger data set, like a class full of test scores? Enter the mode. The mode is simply the number that shows up the most frequently. In this data set, both 12 and 15 show up 4 times. And yes, you can absolutely have more than one mode. In this specific case, both 12 and 15 get to share the crown. So the big takeaway here is that these 3 tools, mean, mode, and median, which we often call central tendencies, are literally your best friends for summarizing any wild, crazy set of data into a single, understandable story. The mean balances it all out, the mode finds the popular VIP, and the median finds the exact, perfect center point. And hey, speaking of the median, I've got a massive pro tip for you that you've got to remember. AC. Just think of an air conditioner. AC stands for ascending order. You absolutely must sort your data from the smallest number to the largest number first. If you just grab the middle number from an unsorted, messy list, your median will be completely wrong. So remember, sort it first, then find the middle. Wow, we have covered a massive amount of ground today, all the way from physical counting to integers, fractions, and wrangling crazy data. So I'm going to leave you with this challenge. Look around you, right now. What math concept from today's explainer is hiding in plain sight in your room? Because remember, math isn't just stuck on a board or trapped in a textbook. It's the geometry of the walls around you. It's the fractions of the snacks sitting on your desk. And it's the data that makes up your everyday life. Keep looking for it, keep questioning, and keep learning. Catch you next time.